Thanks for joining us. This is the first platform engineering meetup. My name is George. I'm the organizer, and today we have three fascinating talks. The first one is going to be from Daniel Bergamin, which is make serverless your competitive advantage. So we'll hear more about serverless and Lambda functions, I guess, Daniel. And after that, we'll take a short break, and we have Sana Essid from Trainline doing a talk about evolution of platform. Hi, Sana. And last but not least, we'll have a talk on Kubernetes and open source by Gerald Schmidt. He works at ThoughtWorks. So yes, it's going to be very exciting. Let me give you a little bit of context about this event. Obviously, we are all working remotely, and I wanted to get the community together, get a few people in and get a few conversations started. We also have a YouTube channel where we created a few videos already, and we have a Slack group if you're interested in continuing the conversations there. I can share the links now and also at the end. Actually, they're on Meetup page, so you can find them there. I think that's a bit easier. Right, so should we get started with the first presentation? Daniel, are you ready?
Born ready, mate, born ready. No,
Nice.
I just finished making some last minute touch-ups while you were speaking, so as ready as we'll be. Let me just share my screen. All right, hopefully, let me know if you can see that, George.
Yes, it works.
All right, fantastic. All right, so so today I just wanted to give a quick talk about serverless, just to give you all a little bit of background on what to expect. This is going to be a fairly entry-level talk. I've mainly sort of pitched it if serverless is something that you've heard of before, or like you've seen AWS Lambda, maybe tried a test function or two, but it's something that you're intrigued in perhaps, but you just haven't had the time to get hands-on with yet. So I guess the angle I'm going for from this talk is to just give you a little bit of background information, just enough to be dangerous, and I guess show some of the practical ways that you can use it for small things and start to, I guess, build a bit of fire around the concept. So, quick introduction to myself. I know George from my time we worked together at World First. So I work there as an independent consultant, and I'm currently a trading systems engineer at a company called Maven Securities. So I've spent the last 6 years or so doing various sort of platform-related engineering things. I started out my career doing a lot more development work, and then jumped the fence to do it was like, I'd say it was, I guess, platform engineering as it was 5 or 6 years ago, when it meant sort of like you have a Jenkins that's building AMIs and, just getting into that concept and idea of immutable infrastructure. And it very much like, it was a lot of companies were sort of starting to go for cattle, not pets, that sort of whole thing, and being part of that movement. And since then, I guess I really just enjoyed sort of developing for infrastructure and orchestration a little bit more than just pure backend development. So I've stuck with it and sort of worn various hats in that kind of industry. I know, it's like, I feel like we keep changing our job titles every few years in this sort of space. We've got like DevOps, cloud engineer, platform engineer, SRE, probably more that don't come to mind, but yeah, I guess it really keeps things interesting. And to me, all of them share a lot of things in common. It's, I think a lot of people that are drawn to these sort of jobs are more so towards the generalist end of the spectrum. We have interest in a lot of different, we want to know how systems work, and happy to poke in wherever problems arise. And I think, if you're in that talented generalist sort of mindset, then yeah, that's what we all get out of these sort of roles. So I'll start off with a quick little chat about history of serverless. We'll go all the way back to all the way back to the 50s, when computing was first getting started. So back then we had, I think, a lot of mainframes around, a little bit before my time, but maybe probably no one in here remembers those days. But from what I've read, at least, it's all, the computer was the size of the basketball court, just to do fairly basic things. And at that point in time, it was just completely impractical for most companies to own any sort of computing device, or even universities. Some of them, only the bigger ones, would really be able to afford this sort of service. So at this point in time, the way that things worked was kind of like the cloud does now. You have a few specialized operators that are running these mainframes, and then you have other people that have a punch card they want to run. They have some bit of code they want to run, or some computation they want to do, and they pay quite heavily for the privilege. And I don't think it was perfect. By all accounts, it was something that was quite expensive at the time, and it was something that isolation wasn't perfect. I think you hear stories of people running a card that just bugged out the machine for the entire university for days, and it sounded like a stressful time to be a mainframe operator. So we move forward a little bit. We get to the 80s, and this whole microcomputers revolution has taken off. So we start to go the other way. Microcomputers start to make it practical for any business, or even households getting a bit later, that want to own these devices. It makes it possible. So, things that would have been quite expensive and you'd only get a little timeshare before, now you can own one yourself. You can have it all the time, and you get the isolation from other people's workloads that might break you, or force you to make considerations that you now don't have to worry as much about. So this is where I think this phase moved on for quite a while. It was pretty common here that companies could actually get quite a heavy competitive advantage from running their own tech, just because it was such a nascent field. Companies that had the foresight to see what this is doing and were ready to invest in it were really reaping the rewards through this era. So that goes on. And then we sort of hit the late 2000s. And I think this is sort of where things start to move back the other way again, towards more shared resources. So at this point in time, I think there's probably arguments to be had here, but I think AWS was one of the first to stand up a public computing capacity that really started to commoditize good infrastructure and good practices. The whole idea of being able to control your infrastructure through APIs, it is just really, I think, quite transformational. Starting to offer reliability reliability levels that would cost businesses quite a lot to achieve themselves. This offering that we come to know as infrastructure as a service, where you sort of have your data center outsourced to an expert party, really started to take off. I think some of the drawbacks that you originally had with your shared computing mainframe start to become a little bit less applicable here, just because the model is almost like a bit of a blend. You're running microcomputers inside a shared environment, so you're getting that isolation from other people's workloads, and you're getting the cost reductions. It's not so expensive, but you don't have to worry about running your own data center, basically. So we go a little bit further on, and this is where we start to come towards serverless. So people at this point, we've come to the idea that we want to have shared infrastructure. There's businesses that don't think they derive a competitive advantage from their tech, and all they want to do is run some code. So they start out with shared infrastructure, but now there's a few companies that are taking things a bit further. So I've named a few there, like Yahoo, Pipes, PyCloud, just a few of the real innovators in this space that launch various solutions where you could start to run what is now called function as a service, or serverless. So instead of having to worry about instead of having to worry about the machine level, where you're still thinking maybe about, you've still got considerations around your runtime environment and making that work. You've still got considerations around security, patching, things like that. These platforms are starting to abstract that away and just let you submit some code and have it run, almost like you would on your local development environment. And then in 2014, we have AWS launching the Lambda service, which I think is, a bit of a turning point as well for when this started to become a bit more acceptable in an enterprise sort of way. And it really started to set the world on fire. So 2020, where are we now? I'll go through where I think we are, and let's find out. So what is serverless? So I got this definition from Martin Fowler. I'll read it out. So he's from martinfowler.com, not Martin Fowler himself, but it says service architectures are application designs that incorporate third-party backend as a service services and/or that include custom code run in managed ephemeral containers on a functions as a service platform. By using these ideas and related ones like SPAs, such architectures remove much of the need for a traditional always-on server component. Serverless architectures might benefit from significantly reduced operational costs, and that's, they're not on a lot of the time, reduced complexity and reduced engineering lead time at a cost of increased reliance on vendor dependencies and comparatively immature supporting services. So I like this definition. It gets into a few of the things that are very obvious about serverless, and it also touches on some points that are maybe not so obvious when you first get started. So I think, as we right at the start there, it gets into the fact that the function as a service component is kind of just one part of the serverless architecture. What they call backend as a service here is another sort of really major part. If you're just running function code, that's only so much use on its own. The infrastructure that AWS and the like provide you, like having the ability to sort of point and click spin up a database, point and click spin up an Elasticache, point and click spin up an identity service through Cognito. Those things are like a massive part of the value add and the overall proposition for serverless. And I think it's wise to sort of think about that from point one. And it also talks about the rise of technologies like single page apps. So, function as a service, again, is one element of serverless. I think there's another sort of very trendy, very trendy architecture now, which is like your S3 hosted page, and then that's hitting remote APIs of some kind, possibly serverless in this case. And I think, it's good to see that, or good to identify that as probably the dominant enterprise use case of this tool, or certainly one of the dominant ones. The final thing it touches on is a few of the pros, and here it hits one of the reasons why you might not want to do it. So I'll go into those in a bit more detail, or what I think of those now. Okay, so reasons why you might want to use serverless. I think for me, the first and foremost one is if you've got a lean team and you just don't have that operational capability already, and perhaps it's 2020, you're building a startup, you don't have an infrastructure team, you might have an infrastructure person, but it's not something that you see as being a massive differentiator for your business. So if that's the case, I think serverless really to me seems like quite an ideal fit. I've not, the closest I've got to doing a startup is just participating in a few hackathons where I did make good use of serverless, but to me, it seems like there's quite a few things that you get sort of out of the box with serverless. The ones I picked up there was security. You don't have to worry about patching and deal with that. Of course, you still have other elements of security to consider, but patching is just one bugbear and that, a lot of people would be happy not having to live with. Your reliability. So serverless functions are by themselves, I think, AWS Lambda in itself is probably a more reliable setup than most businesses or most startups certainly would be able to achieve. Scalability. So once you've written, your piece of code and put it in a serverless function, you can scale up. I think the default on Lambda is up to 1,000 concurrent instances of it. So if you imagine a scenario where you might need your website to be ready to respond to a massive increase in users fast, this is certainly one way to do it. And I'll touch on that a little bit more later. Deployments. So I think deployments can be quite easy with serverless with the right tooling. Again, something I'll get into later. And your centralized logging and monitoring. So this is one other one that I think is, perhaps a little bit underappreciated. While it may not be the best solution, you do get CloudWatch out of the box, and you do have a centralized place to collect your logs and be able to query them, which is, again, not something to sort of turn your nose up at. Working at a few places over the past years, I know, like, even now that centralized logging is mostly solved, it's still really not. So you get these things as first-class citizens when you use serverless, and I think that's super helpful for a lot of, especially startup businesses. You get a reduced cost for most standard load patterns. So here I've said, spiky load patterns with a low overall volume are an excellent fit for this. Serverless, one of the ideas is that compared to something like an ECS, you're not paying for the machines when you're not using them. So if your compute profile is fairly spiky, like you get a little bit here and there, and you don't have that much volume overall, this is where you can really save quite a bit of cash on serverless. Of course, the opposite is true, but I'll go into that in a bit. And finally, I think the model of serverless, like just the whole model of the computing, the way it works, has side effects that are quite architecturally useful. So I think, I alluded to it earlier when I said you get that scaling out of the box. The way that serverless works, it sort of forces you to build your functions in a fairly stateless way. And so they almost, I guess it's sort of tough to explain, but if you start writing them, you'll see that it's kind of harder to make some mistakes that may cripple your scalability and reliability. So I think that's quite useful. And also, you get just a fairly easy way to do low downtime deployments, which is, again, something that's not always easy. So quick look at why you might not want to use them. So I mentioned before, spiky workloads are great for the costs. The opposite is true. If you have a very constant sort of workload, you're taking a lot of traffic all the time, or even just, a lot of traffic overall, the costs do add up quite quickly. There's quite a bit of writing on this online, but there's no substitute for experimenting yourself. But the generally accepted consensus is if you would be hammering a large server, you're probably going to be paying more if you build it serverless. There's vendor lock-in. So this is a big one. Some people would say maybe because AWS Lambda is a proprietary product, that is a big lock-in in itself. I think actually, I don't actually think the functions as a service is a massive lock-in just because of how, what we said earlier, they're fairly stateless. If you want to move them between cloud providers, at the end of the day, it's just Python or JavaScript code, and you could run them in parallel, even sort of, slowly migrate off one to the other. What would scare me is those backend as a service offerings. So I've mentioned there, like some like Cognito and Athena. If you start, I guess it's something to keep in mind if you use those backend as a service offerings, which are tremendously useful. I think those are potentially a much bigger lock-in than the function as a service part. So, just pay some attention and consider that trade-off when you're getting into it. The local dev environment can take some work with serverless, although there are ways to make it easier. You have your general microservice trade-offs, which is, as I've said there, you trade off, I guess, you get your smaller, simpler units and your strong bounded contexts, but at the same time, you now have to worry a little bit about network. Serverless does take care of that for you mostly, but it doesn't shield you from all the semantics. So for example, when you're dealing with queues and things, you have to accept that you're getting one or more invocations. Like if you have a serverless endpoint respond to a SNS queue firing, it could be invoked 2 times. So you need to make sure that your code is idempotent. You've got observability starts to become a more difficult problem. Again, it's something that can be managed, but if you've got 10 serverless functions tied together, if you don't think about it in advance, it can be pretty tricky to track that request through all of them and debug it, especially when you've got a storm of logs coming in on CloudWatch. And finally, I think another final reason why you might want to do it is at the end of the day, serverless, if you're running the AWS Lambda product team, one of your competitors is Google Cloud and Azure Functions, Cloudflare Workers. Another one of your competitors is your own sort of Kubernetes as a service system. So I've said, KWAS, but of course there's a lot more. And also, your various PaaS systems out there. So serverless is one way to handle this problem of abstracting the things that you're not good at away, but there are plenty more ways to skin that particular cat. All right, so a quick look at the major players. I'm not going to spend much time on this, but you've got AWS Lambda, Google Cloud Functions, Azure Functions, and Cloudflare Workers. I think the first 3 all have fairly complete serverless offerings in that they have a lot of that backend as a service going on as well. Cloudflare Workers has they're a bit more targeted towards running small bits of code on the edge. I think very recently they've announced a more generalized solution where they're trying to start to compete with Lambda and the others. But at the moment, the state of play is, I think, for most things, the first three are fairly interchangeable. There are some differences in language support and things like that. But once you pick one, in terms of delivering that reliability, that security, that scalability, I think most of the first three are going to do that for you. And Cloudflare as well, within the context of its use case. So, all right, let's take a quick look at use cases. So I've picked out two here. The first one is if you're looking at the enterprise world, which I'm not going to focus on quite as much in this talk. But yeah, so if you are looking at enterprise, I think that, as I said before, one of the ways to find your use case is just by team, or is by the team itself. So if you're a bit of a skunkworks kind of team in a large company, you're looking to, or you're being pressed to innovate and deliver fast. If you can do it in concert with the existing, or as a kind of POC inside the organization, that may be a good way to look at, or a good way to get going with serverless. If you've got a small team that's just doing its own thing a little bit separate from the rest of the organization, that can pop up. And then by platform as well. So some teams, I think in the enterprise, if you're already using an infrastructure as a service provider, Amazon, Azure, or Google Cloud, I think there's a lot of opportunities to augment your existing workloads with serverless. Especially apart from the sort of going all in on your application design, it's also a useful way to do sort of periodic cron type jobs. So batch workloads are one, having like a reliable batch scheduler that's not cron, that's, I think, something that serverless is pretty good at. And in fact, that's how I first found it and started using it back in 2015. We're just replacing sort of cron type jobs that we had problems with, I don't know if many of you guys have tried to you've started doing cattle servers, but then you also have crons and batch jobs, and sometimes they don't work the best together. So the other one I want to touch on is the personal use cases. So this is where I think it shines for me. Again, reliable batch jobs and notifications, and I'll get through a few more specific use cases in that after this. As I said, hackathons. So whenever I've went to do a hackathon, I've pretty much always picked up serverless as a way to back, I guess, whatever I'm writing. It's just a great way to deliver code quite quickly. And finally, pretty much anything that I want to run that's not going to be running on my local PC. I have sort of one free server that operates in free tier, the server that operates in AWS, but most of the bits of code that I want to schedule, I prefer to keep in serverless. Right, so, okay, so now a very quick look at serverless.com. So serverless.com is a framework for serverless. It overlays all of the different cloud providers. You can use AWS Lambda, or even IBM OpenWhisk, if that still exists, as a backend, and you can deploy your functions to those. So I've sort of put this quote front and center because to me it says a lot about what serverless tries to be. If you go to their homepage, they've got a tweet from someone called Dr. Papa that says, "I didn't realize serverless was so absurdly quick and easy to use. Thanks, you've done a great job." And that's pretty much what it was to me. I first used this serverless.com framework back in 2014 or 2015 when it was launched. And it was also around the time that I was getting into this whole DevOps and platform space. And it was probably one of the first technologies that I got introduced to that actually made my life easier right from the start. A lot of the other platform tools, you think like Immutable, back then it was Immutable AMIs with, Jenkins, baking things with Packer, you have Ansible configuring them, that sort of stuff. And you have maybe Jenkins orchestrating some red-black deployments. All these things can be done, but they're quite a bit of work to get the payoffs. And there's quite a bit of a learning curve with a lot of these tools. With serverless, I found it was just, but when I picked it up, I just found like I could get started and be productive really quickly. And in fact, it was actually easier to use the infrastructure as code features of serverless framework than it was to use AWS Lambda and API gateway through the GUI. I don't know if you guys have tried using like setting up API gateway through AWS's user interface, but serverless made it a whole lot easier. And usually it's the other way around. It's sort of tempting to point and click because it can save you time in the short run. But here it's the opposite, which is great. So some of the things I use serverless for, or some of the things at the end that I want to use serverless for, just to give ideas, I use it as an inbound receiver for my email account. So if you use SES and you want to forward emails onto a Gmail account, serverless functions are a great way to do that. Stock price threshold notifier. So if you want a way to if you're monitoring a stock price or some stocks that you own and you want to see what's going on and do some calculations that are a little bit more than whatever your broker offers, then serverless is sort of a great way to scrape things off the internet and run some calculations and trigger a notification. Again, personal financial status, so just aggregating some details from banks that make APIs available. It's handy for that and presenting them in one place for me. This last one I'll go into, or the next one I'll go into a little bit, which is I use it just for, or I've brought it out a few times for bookings and things, like hotels or restaurants that are hard to book. It's a nice way to poll things and get a result. You could probably have used it for your shopping carts back when that whole thing kicked off a few months ago and it was impossible to get a card anywhere. You can use it for, so I've got a few more things here, but it's, there's a lot of things that you can use this for when you put your mind to it. And I'm sure you guys have got your own things where you've just thought, I'd love to run some code in the cloud, but I don't want to stand up a server. It's too much effort. Yeah, this is where you go to serverless. So I was going to do a very quick worked example, just screenshots, just because live coding things bite me all the time, but I think it gets across the point. So I had a need a while ago. I was going to go to this Blue Lagoon hotel in Iceland for like a anniversary, which was really exciting. Not happening now, but this place is really hard to book. So we had, it was completely booked out for the time we wanted to go. So I thought, people cancel all the time. Let's put a little serverless function that polls an endpoint. We can have a look at the booking API, give it some dates, and it returns an availability status. In this case, it wasn't really it wasn't an API designed for internal use. So I apologize to the sysadmins, but I was nice about my scraping not running too often. So we're just grepping for strings that come back. And then finally sending an email or SMS to notify me that, I can go and book now. So if you think about these things, they sound pretty straightforward, but if you had to create all the infrastructure for this yourself, it might take you a little while. So in serverless, this is what it looks like. You can see at the top there that you specify your provider. This file here is a file called serverless.yaml. So if you go to serverless.com, there'll be a little setup guide, and I'll also make some code available if anyone wants to see it after this. But the sort of stuff you're defining is pretty simple. You give your service a name. You can define, or you can use custom variables, anything you choose. So these come in pretty handy if you want to build pipelines or things like that. You imagine that you could define a variable for the environment that you want to be in, and then just pass that through on the CLI. This provider block just speaks about who you want to use as your backend. So for me, that was AWS. I'll cover my shame of Python 2.7. Just don't look at that too closely. There's sensible defaults for most things, but this is how one of my files look. And of course, in here, there's an inline way to do IAM roles. So if you're familiar with AWS, it's just essentially what this is all doing is it's feeding into a CloudFormation stack. So this is a sort of language this transpiles to CloudFormation. So when you're done, it's going to spit out a CloudFormation stack as an output with all these things configured. So we look down here at the functions. This is where we define the code we want to run. Here I've just defined one handler, which is the thing that looks for the booking. You can pass in environment variables. So this is sort of very useful for your whole 10-factor app. You can think there's quite a bit of config you might want to externalize here, and there's a whole bunch of providers that you can feed in as well. So, one thing is if you want to keep your secrets secret, there are providers for like AWS parameter store / secrets manager where you can feed in usernames as passwords, and that's as simple as just making sure that your function has the right IAM roles to be able to fetch those, and then you can pass it in straight here in a very simple syntax. Here, this looks a little bit complex because I'm using an existing topic. If you want to create a new SNS topic, it's really good to do that. But one tip I have for you, if you use this for yourself, is to just create an SNS topic, subscribe your phone and your email to it, and then all of your functions can just very easily get access to that like this. And you get the ability to notify yourself about things super easily. And finally, events. So this one here is how we schedule a function to run at a certain time. That you have to be aware when you're using things like this. The general rule for when serverless functions are being triggered is that you tend to get like at least once semantics. I'm not sure if it's exactly applicable at this case, but it is just generally useful when when you're making a serverless function fire off an SQS queue or SNS. You're sort of usually getting these at least once semantics. So you just have to think, when I schedule my code, just be aware it might run twice and have a think about what that entails in your design. But this is how you schedule a cron. So something that runs hourly is as simple as that. And finally, this is what it looks like to deploy it. So you get, I'm not going to show you my code here, but I will make it available in the Slack after the meetup. But once you've got this serverless.yaml, you have a Python function, and then you just run this SLS deploy command, which does the magic. This creates that CloudFormation stack we were speaking about. It zips up your code, puts it on S3. If you wanted to have a public API, you could have it set API gateway endpoints up. It does sort of your blue-green magical switch of the code. Does all that stuff for you. Just run serverless deploy, and your function appears up in the cloud with everything configured, which is pretty fantastic, really. And the final thing I wanted to show you is this really cool command, which I found after a little while of using it, but brought me great joy, which is this SLS invoke local. One of the things about serverless that is a big sort of criticism is that what about local dev? We don't have that serverless. How do we test locally? We don't have AWS Firecracker VMs running on our machine, probably. What serverless does, or what this framework does give you, is a very close approximation of the AWS runtime environment, and which is really super useful. One of the other things that you should know about is AWS makes like a DynamoDB local tool available as well, which plays quite nicely with this. And with these two things, you can actually set up a local function as a service runtime, and then you just trigger them with the invoke local, specify your function, and away you go. You can run it without having to jump off to the cloud. If you do want to run it remotely, you can just get rid of the word local there, and it will trigger it in AWS and pipe those CloudWatch logs straight back into your terminal, which is a really useful way to run the functions as well. And I think that's about it. There's actually, just back on this, there's quite a few more commands that are super handy just to check logs and things. Once you've got serverless running, you pretty much never need to touch the AWS UI, which is pretty great. So some final parting tips. If you are going enterprise with this, I think just doing proof of concepts is a really good way to get started with serverless. As I said, it's a technology that this framework in particular is pretty lightweight in the sense that it's very easy to get started with, and it will, you can in a day get a test function up and running and doing productive things. I think if I was going enterprise with this, especially on an API sort of build side as opposed to batch jobs, I would be thinking about observability right from the start. So have a bit of a read about AWS X-Ray and other related systems which let you do sort of distributed function tracing. Sounds terribly complex, but pretty much it just entails sort of passing a unique request ID. So when your customer hits one endpoint on the website and that request passes through 10 functions before it ultimately comes back, they just all are tagged up with a unique ID, and you can get that visibility across the board of what's happening, which is super helpful to have. I've got here do abuse global state. This is a super helpful one that I found, which may not be obvious. It's both a blessing and a curse. So if you, in a lot of the serverless worlds, behind the scenes, AWS is, running up containers, and it's sort of the equivalent with some of them of when your serverless function is what they say warm, when it's running frequently, they do keep it's almost like your execution environment is there but suspended. So if you start declaring globals, they reside in memory, and the next time the function is invoked, they're still there. So that can cause a really confusing bug the first time you're doing it. If you're not paying attention, you might be wondering why your function is just behaving, probably a global state if you're using globals. But once you get used to it, it's actually super useful. So if you have a function that's, say, loading a bunch of data, a bunch of config data off Dynamo, before it goes and does its things, you can load that config, whack it into a global variable, and then just have a simple function saying if it's set, or you query Dynamo, just check when it was last updated. If if it's not more recent than a certain amount of time, just use the cache. And it's a good way to, with serverless, you're really going to be focusing on getting that execution time as low as possible, because you do sort of pay for every 100 milliseconds of compute that you're using. So these little tips and tricks to cache things are quite handy. And finally, I've said, do take baby steps. So I think with this, the best way to do it is just get started. For me, it was, we sort of had this problem of crons and sort of trying to marry up crons with the cattle world. And serverless was, a really interesting way to be able to, just an alternate approach to scheduling batch workloads. And I found that, the visibility and stuff you get out of the box and the reliability was quite handy. And if you just want to get started with serverless personally, I think, I don't have much to say except just have fun with it. It really sort of, I think it's quite joyous to use, to use a framework that is just so simple and just lets you run code so easily. A lot of the time, when you're embracing new tools, it's really easy to get bogged down in, it's really easy to yak shave, I guess, to get bogged down in things that ultimately aren't what you want to be doing. And serverless is, I think it's a great tool for keeping focused and just writing small bits of code that achieve practical things for you. And that's it. So thanks a lot for listening to me ramble for half an hour on serverless, and I hope you got something useful out of it. If you want to be in touch, I'm in the Slack channel that George posted, and happy to answer any questions on there. I'll also put my email address there. And I guess, small plug for the employer, if any of you are looking for work at the moment, Maven is definitely always looking for smart people, so do get in touch about that as well, if you're interested. But any questions before I go on mute?
Nice. Just a reminder, if someone has questions, you have to unmute yourself first. It's at the bottom left. There is a mute button. And I see someone posted about Knative. Aaron, do you want to ask a question about Knative being used as an alternative?
Yes.
Yeah, so one of the things we're doing here at Salesforce is we have kind of our own internal paths thing over public cloud. And one of the things we're looking at is to provide our developers with kind of a serverless experience across multiple substrates using Knative as a means to do that. Is that might be something that's viable kind of at our scale. I don't know that it's like something everybody's going to do, but is that something you guys look at or not? Thoughts on that?
I'll let anyone else that wants to jump in here go. I personally, I've seen Knative, but I haven't used it myself. But if anyone else wants to talk about their experience with it, please jump in.
I think Knative as a platform was actually really exciting, and I'd quite like to use it. And the special power I see in it is that you are still within the control plane that all your long-running services are, and you can now use the patterns. You can architecturally basically make the serverless components really one united part with everything else you're building. What you lose is you lose that incredibly tight integration that, say, a proprietary offering like Lambda gives you. So the fact that the backend is part of it and everything is connected up in one very coherent way. And also, of course, the cost side, because you do have long-running machines that typically you would pay for. So, but absolutely, I've actually been watching Knative. I haven't actually used it in anger at a client. I've only been playing with it on my local install of Kubernetes, but it's really powerful.
Cool. Thank you. That's helpful.
Yeah, in that sense, actually, I was just thinking, like, one of the things that struck me a little bit in finance is like, or getting into the finance space lately, is you learn a bit about companies like, I think JP Morgan has this system called Athena, Goldman's got their SecDB binarize courts, and like a lot of these enterprise companies have been doing serverless like things to let their teams write small bits of code that run in a really convenient way for decades and reaping rewards from it. So I think, yeah, something like Knative sounds like it's really going down that alley and potentially really powerful and useful in the enterprise.
Okay. Any more questions for Daniel?
Cool. All right. Well, thanks very much. And of course, I'm not going anywhere. So if you want to chat later, please do, or reach out on the Slack. I'd love to talk anytime. But yeah, so thanks very much, George, for the chance to speak. And thank you all for listening.
Thanks for your time, Daniel. That was a great introduction to serverless. So if people go to participants on Zoom, they will see some buttons, yes or no, green and red. And just have a quick question for the audience. Who has used serverless before, or Lambda functions? I'm new to this, so it was a great introduction. Learned a few things. All right, so few people have used it. I assume that the ones who didn't respond haven't used it or haven't figured out how to use the buttons.
That's me on the buttons. I cannot work it out.
Okay, I see some thumbs up. Cool. All right. Sana, you're up next.
Yeah.
Do you want to share your screen?
My screen?
Perfect.
All right, presentation mode. Here we go. So, I think we can start. Can everybody hear me?
Yes, loud and clear.
Okay, fantastic. So my name is Sana, and I've been working in infrastructure for now almost 10 years and over, if not more. Stopped counting, really. So I moved to infrastructure in 2008, right in the middle of the financial crisis, if anyone remember that one. So I worked in the city in the banking industry for about 7 years. And then I moved to the cinema industry with Arts Alliance Media, where I helped digitalize the cinemas around the world. I've then moved on to the Telegraph and touched more into the newspaper industry. And 2 years ago, I moved to Trainline, and that's my first job in a hardcore e-commerce industry, shall I say. So where we sell tickets across all of Europe to millions of customers. So that's about me. I'm actually French, born in France and studied there. I studied actually business and accounting, but I've ended up in IT due to also my languages. So there you go. So the subject today will be about the history of platform infrastructure. And the idea came through the fact that, I've worked with so many technologies, which were always like new. And I thought it would be a good idea to go a little bit deep, not so much into the technical side of the history, but rather into the reasons of why we are today using those technologies. So all throughout my career, I could get really confused about so many terms, so many methodologies as well, from waterfall, ITIL, these were back in the days, like 10 years ago. And then you start hearing more about Agile, DevOps, and what are they for, who do they target, and things like this. Not only that, but also the technology that I've used, such as, kind of type of mainframe, very old technology like open VMS clusters and Solaris, no more, not really a mainframe, but more distributed computing already. Going silos and all these terms really that we as technicians, we might hear, we understand, but we really not always understand why we're going down that route. And so I thought I'll do a little history of platforms and why we've moved to where we are today. So which takes us to my next slide. So basically in the 70s, mainframe technologies were mostly used by like 8 government agencies and a big corporation due to the fact that they were very expensive, like Benjamin said, so it kind of sounds like a repetition here. But we were in the phase of what we call centralized computing. And that was from the 70s up to the 80s. With the price then of computing component going down and the advent of the personal computing, we entered the era of what we call distributed computing, and where we used mostly client server technologies, and the mainframe remained really niche technology for big corporations still, but then they went out of the door. In 2009, I think this is where we got rid of some mainframe technologies when I was working at the London Stock Exchange back in the time, and going for more like Solaris and then Red Hat servers. And we spent changed all our application into silos. So that was very early in the year 2000 that I was talking about. So distributed computing with the personal computing has started to appear. That was, and started to be democratized to people with, to have a personal computing in the 90s, early 90s to 2000, where with the advent of the internet, more common people, shall I say, were more interested in having, the computer. So even for my personal case, although I had personal computers, Amigas and things like that, but I really started using them when internet in 1998 was my first connection to the internet, and I started using computers at that time. So with the advent of internet came a new era where so everybody had, most houses had, a personal computer, but not only that, but also mobiles started then in the early 2000s and 90s. Even in the 90s, actually, the first mobile was already in the 70s, already created, but started to be democratized in the late 90s to early 2000. And the funny thing, it reminds me that when I was in Germany, I had a friend. She's Japanese, and she came from Japan, and she had her mobile phone, and she was just trying to buy a Coca-Cola from a vending machine, and then she started tapping with her phone on the machine, and I was like, but what are you doing? And that was back in 2002. So I'm trying to pay, and it just hit me how actually here in Europe we were in the past at that time, and they were already in the future where we are today with, being able to pay with your mobile phone and your cards integrated in there. So it's only when we look back to see that, to look about Japan and see how they were very advanced in that sense. The advent of mobiles, and we see that not only people had only a personal computer, but they also started to have mobiles, and we started more to see basically computing for every person with mobile, and that gave us the advent of web applications. So the motto of anytime, anywhere, any user, which every business then would start to aim for. And nowadays we hear about cloud and also ubiquitous computing. So it's more pervasive computing. I think I missed one. Yeah, with cloud is more like the on-demand. So it's something quite new in the sense that companies can simply start on the first day as a startup and already have a data center. When back in the days, it would take you at least 6 months to prepare a data center, 3 months to get a server ready and installed in your data center. So with cloud, I think everything has accelerated. And these days, it's so simple to have your, infrastructure ready in a few clicks, and you're off to go. So it's fantastic to see throughout all these years. I still remember my days where I had to prepare 3 months in advance to get a server, purchase it, get it approved in terms of budget, and get it installed, have the technician over in the data center and install them, cable it, make it ready for then us to install the operating system, and all these things that really took minimum 3 months. And that now in a few clicks and you're ready and you can go to prod in 2 weeks. So we are in a world where it's compute everywhere. So we see here that with the advance of technologies, we moved from having things in-house in a data center that was within the offices to external data center, and that was also thanks to the internet. Then on to move from external data center to cloud provided data center. Along there with the cloud, when you move to cloud from in-house on-premise to in-cloud servers, you're always encouraged to decouple your application, and that's due as well to the infrastructure. Not only that, it's also for best practices. So back in the days when you had your one application into one server, so a monolithic application, you had various functions within one big block of code, which means as well that when you will be developing a new function or a new features, you could look at a higher time frame due to the fact that most of the time when you touch a bit of the code, it can affect other dependencies and things like that, and it will take you a bit longer. So the sprint time was in the range of like every 6 months, maybe you'll have an update by using the waterfall methodology. So from monolithic application into a centralized server, we started to go more into isolating each function and each code alone. So first one application into one app into one server, and then nowadays we are isolating even one process into one container. So we are isolating smaller and smaller pieces to allow smaller pieces of code to be developed in isolation without having impact to the whole service, shall I say. So yes, so with this decoupling, we went from monolithic app into more hearing about microservices, and the infrastructure itself then with the cloud has become a code, which made basically my skills of hardware technician to be almost useful only for data center providers or for cloud providers. But I had to move on and to upskill myself. So we end up into this accelerated life cycle of application, but not only of application, but also of skills really, where you have to continuously learn new technologies. And now at the bottom, to show that from the computing and how it democratized from corporation, then small companies and medium-sized companies started also to have an IT infrastructure, and then to have each family, each member of the family, we go to the age of Internet of People, and that was with the advent of like social media and everybody having, a Facebook account, a Twitter account, etc., etc. And with cloud technologies, we have enabled as well basically not only people to be connected to the internet, but also things such as all your smart TV, smart cars, all the things that we call Internet of Things, really. And recently in the 2015, we hear more about like nanobots and even xenorobots. So such small computers that are for medicine that they plan to use to deliver drugs or anything that will go inside your body. So here we are, we will have CPU integrated to everything almost. So and I found that quite interesting to see at which accelerated rate we've started from the 70s till now and where we are. Now, all these acceleration have also has affected people and then also businesses. So the reason they always have like business, there is always business reason for why we are here today. So all this decoupling of application and these, going into smaller codes and everything was actually also encouraged by the fact in business, we have different strategies. We have the advent of more customer-centric strategies where every business, even those who didn't necessarily develop, for example, application or anything, started to even do that to offer their services and their products. And that was to be basically anytime, any place, anywhere, for you to be able to offer your services through the internet first, but also then through the mobile. And this is where we had the evolution of mobile application. And also the advantage that you get by being first into the market with a new feature. And that has driven basically even more further those new methodologies to accelerate the pace at which we deliver small functions and small codes to deliver them. And this is how the agile methodology came to be. And we try then to develop in an agile manner. And then when you develop so quickly and deploy to production as well so often, coming as well from an operation background, usually you're like, okay, you can't be deploying every day. So it was quite a steep, step for those who are maybe more senior to go into the world where you had to deploy every day, especially when you're in operation. Most of the time when you deploy to production, you have your fair share of calls or of issue that comes around with it as well. But over the years, it has become the norm, and people have got, better at it. And with the advent of like the DevOps methodologies, where you start to learn on how to better deliver a small piece of code in the best manner. And recently, with all these, which used to have like 10 maybe application, and now you end up with 700 microservices, you do lose a little bit in observability and things, but you have to adapt as well. And this is where we hear more about the SRE, and this is meant to be a methodology to know how to operate best your services, to have them anytime, any place, anywhere, and if possible at 100% availability. So these are all the reasons as well that have driven to the use of the technology that we are using today. And so it's interesting to see how technology has obviously affected the human being, but also then how the human being has adapted his business for it and has adapted his methodologies for it. So when we first started in the 70s of having one central computer and many people through terminals connecting to the mainframe, then to have distributed computers and people having their personal desktop, and then to where we are today, where everything even is on mobile phone and things like that. And when you have actually one human having various computing devices, from their laptop to their iPads to their phones. So we see a multiplication of CPU everywhere, like I say. So the consequences as well for that, we see as well how technology has allowed businesses basically to disrupt markets. So that was the case, for example, with AWS when they launched the cloud. They become big player of basically offering computing when the very first core of their business was not necessarily computing. So this is how they challenged big players such as, I don't know, at the time Dell, or you can think of Cisco, or and all the other big player in computing, HP and all that. So and it's not only actually in IT companies, but also like in the banking industry right now, where there is bigger adoption of cloud technologies. I think at first the banking industry, for example, did not want to go into the cloud for security reasons, but now with with the knowledge and with the advancements, I think more and more have started to adopt it, especially when they saw small financial startups, such as I'm thinking of Starling Bank or Monzo Bank, they start to change the game. And also a new generation, it's also a generational gap where we see, the millennials using their banking services in a very different way from the previous generation. And so you have these technological shifts that goes with generation. So it's not only, so the technology is here, and when you have a new generation that's grown up with technology, they will use and consume services in a different way. Having worked, for example, at the Telegraph, I remember that most of our subscribers a couple of years back were mostly seniors, and they were used to the paper version of the Telegraph, and that was bringing most of the revenue. And over the past 10 years, they had to move into a digital and invest heavily into their application for them to be able to attract the new generation and to generate revenue from the new generation, because they saw that the senior generation was disappearing bit by bit, and their subscribers were disappearing as well. And so you had to do those shifts. And when a business doesn't do those shifts, it most of the time has everything to lose. At the tech level, what we saw is also like the shift to coding infrastructure. So gone are the days where we have to build a server from scratch. There are still certain industries, where, for example, the cinema industry where I worked, because they deal with very huge files, so they didn't adopt cloud because it was not possible. You can't transfer a 10 terabyte file. Or even like The Hobbit was like 40 terabytes. You couldn't like just send this over the internet. It's just not possible all across all cinemas. So you were still sending discs. So I'm just gonna sending discs for the films when you in content distribution. Maybe now with the advent of Netflix and cinemas might go down the route of streaming. Who knows? So this is where we see basically that the technologies do allow new business opportunities, and if you don't adapt, well, you most likely die. So that has opened many opportunities for a lot of businesses. And I think that's what I like with the cloud technologies. It has accelerated so the Internet of Things and new businesses to come. And who knows as well now with the nano robots and things like that, where are we going in the future? And that's what I find that is very fascinating. A computer in every aspect of human life. But not only that, we've seen as well, like with the advancement, of the augmented reality and virtual reality, where it's the human being going into the computer world. So yeah, I think how does that will affect, how will it affect humanity for the future? Only we will know only when we will live, I guess. So yeah, so it opens up a lot of question when we study, history and how basically platforms have been changed due to businesses, but also businesses changed due to humans, and then introduction of technology changes human, which also changes businesses. And it's very interesting to try to, break everything together to get the full pictures. And so, yes, if you have any question, because it can be a very passionate subject. So I've put a few resources because I haven't been inventing all this, but there is a very good video that I introduced into ubiquitous computing. This term actually has been coined by Mark Weiser, who was a Xerox employee. And that was in the 90s already. And a YouTube video about nanobots, because that's also very interesting. So for any contacts, do not hesitate to add me onto LinkedIn. It's ESSID is just my login. And if you have any question and answer.
I guess for me, that monolith pattern. A lot of companies have regretted it and are now trying to break down monoliths into microservices, but it has its use cases.
Yes, it does. Like I was saying, certain industries, like the cinema industry, for example, because they use very big files, they're not yet jumping into the cloud, and therefore they haven't yet, functionalized per function their application. They're still using some monolithic one.
Looking at the comments, I see Dennis posted something called LiveScope. Do you want to elaborate, Dennis, what's that?
I was just musing on the idea of where things will go in the future. LiveScope is two ideas threaded together. One is scraping all of your personal information from many different data stores, which can be either good or bad. Like it can either let you see how much everyone knows about you, or it can be also abused because this sort of system allows someone else to scrape a lot of the stuff about you if that integration is set up. The other one is around 3D and 3D visualization that brings. So a lot of the stuff that's been happening now in like the retail sector because of COVID and because retail is down, but people don't want to go and buy stuff. So one of the potential things being looked at is doing more augmented reality and even virtual reality for shopping experiences. Don't know if that will change how you'll necessarily decide to buy shoes, but
yeah, I'm sure the new generation will have new habits, and who knows, maybe we see the amount of time that children are spending on computers and on gaming as well. So they might just extend their world into a virtual shopping and virtual everything almost. And we see more cases as well in Japan where people are just, focused only on their virtual life almost and less apt then to do even like, social, relational. They're very much lacking in that.
Hikamori's or something, was it?
Yes.
But this augmented stuff is really going to bring about a change in infrastructure just to power it as well.
Power that it needs.
Yeah.
All right. Any other questions for Sana? Cool. Okay, Gerald Schmidt is next. He's going to talk about Kubernetes and open source. Gerald, the stage is yours.
Fantastic. Hello. Let me just share my screen. So I'm Gerald. I've been in the Kubernetes world now for quite some time. So April 2016, I looked it up not so long ago, was the first time I worked on a project. So I'm a consultant with ThoughtWorks. Really, I've been specializing in infrastructure now for a good number of years. I think 2013, 2014 was the first time basically I made that my main interest. Yeah, and then over the past 3 or 4 years, really, it's often come down to Kubernetes, not always, and rarely just that, but I don't know, it's become an interest of mine. And so what I wanted to talk to you about really is where I see it going and why I think it matters, why I think it might matter even more for those of us who are open source fans. So I actually entered the computing world via open source. So that was very much my entry point, and I feel very passionate about it. I think that it has an awful lot to offer the world. I also think that this is actually quite a tricky time for open source. And we'll touch on that in just a moment, sort of why that is the case and why I think Kubernetes has an important role to play here. So I wanted to start really with the sense of where we were a few years ago. All happy families are like, and right, this was one happy family. I know, some people called it the orchestration wars. It didn't feel like that at the time. It felt that everybody was excited about Docker and everybody had a different spin on it. In-house spins, and lots of people sort of had commercial products, just ideas. Let's just whip something up. It was really, I think it was quite a glorious time. You had all these competing solutions. And even sort of, if you look there, you see OpenShift 1 and 2, which was entirely Ruby based. And so a long time ago, of course, Heroku, and arguably still most Kubernetes clusters you see, they all want to be Heroku when they grow up. At least that's what often the developers would like them to become. Now, just a couple of years on, it looks very different. And I think with that comes quite a lot of sort of weight that now rests on the shoulders of Kubernetes. So basically there was all the promise of what containers would bring. And Docker is really quite amazing way to condense into a very simple user interface, into a very simple command line interface, paired with that really neat sort of stacking of the history of the container, how everything worked together. This was the first time it came together. And then the question about how you would orchestrate these things occupied us for some time. And now really that sort of work has to rest with Kubernetes, because the competitors are mostly now no longer at least contesting that particular space. So Kubernetes is left standing, and this is only really very recent, if we think about it. That happy family picture that we saw before really is also very recent. Now, of course, this didn't happen in isolation. And what I think we need to look at in parallel is also how did the public cloud evolve during this time? And this really is a chart that blows my mind completely. If we go down to 2006 and we see this is when AWS got its start. And the really crazy thing about this chart is that how long does it take the dark blue, how long does it take Google to actually launch a competitor? These 5 years are incomprehensible to me. Just think about for a minute, right? You had 2 breakout new product releases in the mid-2000s. This was the iPhone on the one hand, and this was an AWS on the other. The iPhone was pretty clear to everybody pretty quickly that this was a big deal. With AWS, it took a little bit longer. But if you imagine for a minute that Google had said, we're not sure, let's sit on Android for a bit longer, another year, another 2, 5 years, there would be no Android today. There's no chance that Android would have got anywhere if they'd given the iPhone a 5-year head start. So this is what happened here. It really is remarkable to me. Also, if you think about things that make it even more remarkable, there's some people here who aren't actually direct competitors. You can look at Microsoft, and of course their offerings, their public cloud offerings, are in many ways comparable. But really, they're in the wonderful business of converting their installed Windows base. That gives them a wonderful uplift that enabled them to really sort of scale out. And you see here the sheer number of regions they added. So data center after data center after data center, because they had the customers there already. They could just fill them out. They could really sort of use that to grow massively. Also wonderful in green, Alibaba, who for a very different reason weren't competing directly, because they were in a geography where basically they couldn't be contested by Amazon. And I remember actually in the first trial when the Beijing region first opened and my CloudFormation broke. And I thought, what happened here? They only had 1 availability zone. Sort of, I had my template set up so they could have either 2 or 3 availability zones. That was basically in my normal set, but in that there would only be 1. Sort of, you could really tell from the beginning, Amazon didn't really have a chance there. So again, Alibaba were here, and them sort of, they could grow and then really sort of make the most of this. And it's been toughest for Google in an odd way. And I would be very surprised if there's nobody out there kicking themselves to have given AWS this 5-year head start. So that it just strikes me as remarkable. Now, what happens if you give somebody a 5-year head start? This is what happens. So this is sampling I took just a week or 2 ago. I thought, hey, I'll just output these and then I'll sort them and put them in text form. It's really incredible, right? Sort of, if you think about it, so if you're going to be fast follower, you better be very fast. Android was a fast follower, and it was nowhere near the polish at first. It didn't have anything really to compete with, but it went in there, right? It was a fast follower. It iterated rapidly, and it sort of spent a lot of money, spent resource. Now, what do you do if you're competing with this? What do you do if you run a public cloud and you're up against this? And that's what I want to talk about today. Sort of, I think this is really absolutely crucial. This is the backdrop to much of the development we've seen here. This is why people are buying up data centers more quickly than basically anybody can figure out what you're going to put in them. And so again, sort of just as a snapshot in time, if you think about where we are today, this is an absolutely incredible achievement by AWS and what they stood up in so short a time. Now I'd like to talk about something, I think of it as the Horcrux pattern. Now, those of you not familiar with Harry Potter may want to know that there's only one impressive thing that the villain of Harry Potter ever does. And that is he splits his soul into many parts. He deposits bits of his soul in various animate and inanimate objects. And in order to defeat him, you need to defeat all the Horcruxes first. So that gives him wonderful resilience. And it's also very powerful if you think about it, sort of when, after all those long books, Harry finally does defeat him, it's actually an interesting point where Voldemort actually returns to being childlike and crying. So taking us all the way back, those 7 volumes, back to the first volume, Moaning Myrtle, and also, of course, to the fact that he and Harry Potter have been alter egos all along. They're both lonely orphans. So it brings everything together. If you ask me, the Horcrux pattern is the single most imaginative and compelling thing about those books. Now, where does that apply to Kubernetes? The amazing thing, whether by design or partly luck, probably a combination, this happened. So here was Google. They had the foresight to see this would be something big. So they seeded development. They worked with the community. They had wonderful outreach people who went around, and they set up the Cloud Native Computing Foundation. For a while, I was wondering, the Cloud Native Computing Foundation, and it seemed to be all about Kubernetes, and that really was the point. So this was a home where Kubernetes could flourish. And how did it flourish? By essentially becoming a co-op. By achieving that every large player in the industry came to acquire or build a significant part of it. Everybody owns this thing. Everybody owns a stake in it. And in order to kill Kubernetes, you're going to have to kill each and every one of those shards of the soul of Kubernetes that have been deposited all over the world. And again, importantly, there's important work happening there at Alibaba. There's important work happening at VMware. And this is obviously a very, very incomplete selection here. The number of companies who make very significant contributions is vast. I'll just pick out one. CoreOS, I think, is the often unsung hero of the evolution of Kubernetes. It's absolutely incredible if you think that CoreOS is the originators of etcd. How have time and again, their innovations have been absolutely key to how this happened. And I don't have knowledge, but I'd love to have been a fly on the wall when those acquisition discussions were going on, Red Hat buying CoreOS, and then of course IBM buying Red Hat. And surely part of that calculation must have been that Red Hat made an excellent acquisition in bringing on CoreOS and the innovation they drove. And of course, some of the now leading people in the Kubernetes universe, like Kelsey Hightower, they started out at CoreOS, so they worked there for some time. Now, there's some preconditions for setting something like this up. In order to create a co-op like that, in order to have the CNCF, the foundation, in order to have everything work together in that way, for other companies to feel that it is in their commercial and generally in their interest to do this, you have to have several preconditions. Now, one, which is necessary but not sufficient, is you have to have an open source license. In this case, a permissive one, for which I mean it's a library based one, which means that you can repackage and you don't actually have some of the more onerous demands of the second and third edition of the general public license. So you have a permissive license. That was really, really important. Building on that, you have the neutral IP ownership. This was the special ingredient that the CNCF brought to the table. And I think it's important here that Matt Klein of sort of now very central to the ecosystem as behind the Envoy proxy, Kubernetes would not be what it is today without neutral IP ownership. And this entire ecosystem came to be because it can be used by consuming projects without fear. I thought that was really powerful. It was very recently, and only in February he said that. I think it rings really true. I think especially that's interesting in the context of more recent projects no longer being gifted to the Cloud Native Computing Foundation. Gives that an interesting context. The third crucial ingredient is extensibility. And not just extensibility, what happened here was that Kubernetes gave extending teams access to the core reconciliation loop. Many people come to Kubernetes, it's sometimes said, for the containers, and they stay for the reconciliation loop. It's the fact that you've got a constant revolution of sort of your state and always compared with the desired state. And there's the API server, there's the whole machinery of Kubernetes, which is really just there to make that reconciliation happen, to check, okay, have I reached my desired state? No, okay, I'll try to get to my desired state. And so you have the controllers paradigm. Now we've had that for a long time. And the controllers basically just allow us to tap in, to listen in on event changes, any objects, anything that flies in the Kubernetes control plane, we can listen in on. And then you had the operator, which really pairs them with a custom resource definition. That meant as a company wanting to invest in this ecosystem, perhaps build a distribution of my own, I could now go and say, actually, I call this thing the Vault operator. And then I can build within that whatever I like. This is, for example, what CoreOS in fact did. So the very first operator they created was Essid, an Essid operator. The second one was Vault, their Vault operator, which in turn used the Essid operator. So a very powerful system that gave everybody who wanted to extend the system full access. Now, what that enabled in turn were a number of pizza effects. So just if the term isn't familiar, we're thinking of immigrants from Italy, especially in the 19th century, going to New York and opening restaurants. Now they thought, okay, what's a good dish to prepare here and sell to the New Yorkers around us? And they remembered this dish, little used in Italy at the time, the pizza, and they completely reinvented it, right? Pizza, as we know today, is New York pizza. So they reinvented that. But of course, what happened then, it was so successful that they thought, oh, some of them actually went back to Italy. They thought, hey, I'll re-import that. And so it got re-imported. And now if I go to Naples and I buy pizza, what I'm really eating is New York pizza. Of course, now again with a special twist, with a special sort of local coloring again. So you can see how this has come full circle. And this is precisely what a strong upstream in an open source project makes possible. I wanted to give you just a few short examples of that. For example, for identity, right? Kubernetes had something very, very basic. I barely used it because it was soon replaced, thankfully. It was attribute-based access control. It was quite crude, quite simple. Now, Red Hat saw that. They wanted OpenShift to have an edge over plain Kubernetes by being enterprise-friendly. So what they did is they came up with roles and cluster roles in order to be more specific about this, in order to have a better framework around this. This came back to the upstream, so they contributed that back, and what Kubernetes did, and when it got finally merged, this was fully fledged role-based access control, which today we're all using. I don't see anybody using ABAC anymore, and so this innovation, essentially the New York-style pizza, that were the roles and the cluster roles, have now been re-imported and are now a core part of Kubernetes itself. Similarly, we can look at deployments, where Kubernetes initially offered you pods and replica objects. OpenShift again took that. What do we want? They came up with a deployment config that then got re-imported as the deployment object that we're using today. And again, this is an interesting one actually for networking. It began with a flat network. So Kubernetes did not have a concept of this, did not seek to impose policies, any restrictions, whether you were in one namespace or another. You could always practically see all other pods. So OpenShift, actually, this was one that I loved, the multi-tenant plugin that was proprietary to OpenShift at the time, which basically you gave each namespace a number in the unsigned, in the signed short range, so up to 32,000-ish. And basically, if two namespaces had the same number, they could talk to one another bidirectionally. And if any had 0, then that counted as a global namespace. So everybody could talk to that, which was very powerful. But it didn't really stay there for long, because then came the prototype network policies, which then in a final pizza effect came back as network policies that we're using today to shield one workload from another. And with that, we're coming to the core topic of today, really. So how does Kubernetes deal with state? So that remaining central conundrum. And there, the original message from the Kubernetes makers was beware stateful application. This is not what this system is there to do, and it's not ready for it. So Red Hat came back with application templates, which made it look kind of plausible, but to be honest, the answer was they're still hard. This still isn't quite working for us. Then came the CoreOS team. So their distribution Tectonic now appeared on the scene, and they had the Essid operator with third-party resources, they called it. So the other parts that we'll be talking about, the operator framework, didn't exist yet. So what was needed then, that third-party resources became, when this came back, the custom resource definition, which now was a core Kubernetes feature. And once the custom resource definitions were in place, it was possible for CoreOS to innovate again and actually formalize this as the operator framework in SDK. shortly, a year later, they pretty much merged with Red Hat OpenShift. So what we see as OpenShift today really is the union of OpenShift and Tectonic and all the innovations that went in there. And that takes us to the operator life. So what does the operator life entail for us? Typically, you would have a custom resource definition, as mentioned in brief. So for example, this might be Vault Service. If I install the Vault Service operator, what I will do, it comes with a controller. The controller will pick up on there being the Vault Service object. It will basically, any change to that object, it will act on. It will then basically be responsible for that part of the reconciliation loop that affects directly the Vault Service. And in order to do so, it has got full access to all the powers of the cluster. So it has got access to cluster states in the form of etcd, persistent volumes, config maps, secrets, you name it. Basically, all the primitives that everything in this ecosystem has available to it, you can do from there. And from that basis, the operator ecosystem was allowed to grow. Now, this is where we have to say, are we there yet? And I'm afraid the answer probably is no. And maybe no, perhaps for another year or so. I wouldn't want to guess too much. I know a lot of people are experimenting with this in earnest. I know also some companies that have taken this to production in quite a consistent way. But it's still important in the very blog posts in which Brandon Phillips introduced the operator as a concept. He said, stateless is easy, stateful is hard. So there is an acknowledgement that this is not a solved problem. This is not easy. We shouldn't fall for this. Oh, this is the new panacea. Let's just do nothing else. It's not that kind of thing. It's really, it's about sort of what is the direction of travel here? Where do I see the greatest possible payoff for perhaps a smaller investment to see how this will go? And there's a lot of backing for this. So if you look at the Vault operator, as our first example, this was CoreOS themselves. The MySQL operator has got Oracle backing it. And if you want the PostgreSQL operator, this will be Zalando in Berlin. So a lot of companies, and this is a long list, right? Sort of, if you're running an open source business and you've got a database, you sure need to offer, basically for your clients, all the people on managed Kubernetes services, you need to offer an operator for them now so they can actually install it easily. And you can sort of support them in the way that the operator will take care of. I know how backup works for this particular database. So the operator will have a method for that. It will know how to back up. It'll know how to go back to a snapshot. It will basically, all these sort of tasks will have been formalized and made available. Now, if we take those two large scale developments, so we look back over the meteoric rise really of AWS and then the other cloud players, and then we look at what happened for the open source companies producing software, creating databases. And many of these are they've issued stock, they're publicly traded companies. So this was really, it amounted to a very public breakup. We began by looking at Voldemort splitting his soul. This really, really came close to splitting the soul of open source. When MongoDB in 2016 released the server-side public license, this was as close. This was, I would argue, the biggest crisis that the open source world had seen since those early 90s and early 2000s, perhaps, when Microsoft were at the time claiming that the whole concept was invalid and it would basically collapse under litigation soon. So this was real risk. And what was behind this was that AWS perfected the use of proprietary services that they would make available to their clients based on open source products. And that made it really, really hard for a company like MongoDB Incorporated to see how are they going to make money of this. If the users are going to go for the wonderfully supported, wonderfully stable packaging that AWS can offer, then they didn't see a clear path to profitability anymore. So this was really scary for those companies. Now, I remember some episodes of the Software Engineering Daily where it was blithely said, oh, well, they should take good advertising. This was advertising and they were doing fine. I think that's casting them off too lightly. I don't think MongoDB Incorporated made this choice lightly. I do think they saw this as a vital threat to their ability to operate, to their core and business model. And I think they weren't entirely wrong. So the core really is, if we look at an example of a stack here. So we've got the secrets manager, we've got RDS under that, of course, we've got MySQL, the Postgres, the Oracle, if you like. And then we have the Kubernetes offering, and we have code deploy, SQS, the queues. Basically, you have all these proprietary products coming together. And you can see why it might feel to a company that has basically made it its business to sell open source solutions, that this is quite a scary situation to find yourself in. So how about this as an answer to it? If we say that we have a portable stack, and in there, instead of secrets manager, we have the vault operator. Instead of RDS, we have the PostgreSQL operator. We have Kafka instead of SQS. And for the pipeline duties, we have Jenkins X, probably backed by Tecton pipelines. If we take that offering for a moment and we say, well, what if that's it? What would that mean for us? And this really takes us to the concept that Kelsey Hightower, I think, first floated just under a year ago, when he first spoke about infrastructure as data, which was really about sort of, this is defining an infrastructure in a way that goes straight to the reconciliation loop, is concerned mostly with whether this is already the desired state or whether it has to come closer to the desired state, and how that is a loop. This is not just an A to B, but this is actually a continuous process of becoming. And that allows us to take a very different look at this. So if our lens for a minute is desired state, we can look here at the top. We have the secrets manager, RDS, all those. These are really Terraform is doing this for us. We've got a plan, apply, save state cycle. So quite straightforward in that sense. There's only a tiny bit where the reconciliation loop is even relevant, right? This is only the bits that happen in EKS. There's no reason why you would have to use that here. So as ECS in that kind of scenario, it works absolutely fine. So the really interesting things happen when we now say, what about infrastructure as data? What about, we say this is any managed Kubernetes service. We've only now got the outermost bits to be done by Terraform. So we plan, here's our infrastructure, we can tear it down again, we can look at it, compare it, all that, but everything within, our queues, our database, our secrets, our workflow, everything is part of that one reconciliation loop. And that really is the core promise of infrastructure as data here. And we can go further. We can say, what this actually gives us as developers is a reduction in complexity for the first time. Often the criticism leveled at Kubernetes is, well, this is a complex system, and it is. But for once, it is a complex system that does promise to eliminate some complexity around us. Whether it succeeds in that remains to be seen, but I thought it's at least interesting to think of the original configuration now with an EKS-based system where we have RBAC, we've got the network interface, we've got the storage interface. And they then, of course, have to translate to IAM, to security groups, NACLs, to S3, EBS, and so on. And then we've got reams and reams of Terraform code. And compare that with using those same three ingredients. We've got RBAC, we've got the networking, we've got the storage, and then already we've got the Terraform. Probably divided by 10, I would guess, in terms of how much actual Terraform we need. Of course, we would gain in code that runs inside the cluster. And that just really leaves us with a few questions. Can I trust custom resources to create these native objects? And there we have to say, hold on, our services have done this forever, right? They're creating load balancers. If I have a persistent volume, that too creates an EBS volume, or it works with an EFS volume. It can create buckets in S3 storage for us. So there are various things here that we can do. No, actually, sorry, that's actually not a good example. They would have to be done differently, but we can imagine a controller that would deal with buckets specifically. We couldn't use them as a system for them. And then there's the service level. Well, can it compete with the RDS? What about availability? What about durability? And the answer really has to be no, not today. But we have to say the storage primitives underneath are the same ones. So when RDS is being constructed behind the scenes, away from us, they're also using EBS, they're using EFS. I don't know what exactly, how they're putting these together, but they've got the same storage primitives to play with. So there's no reason why we can't ever reach that kind of stability. And the other thing is, until the situation improves, we could just say that our operator, if it happens to be on AWS, it could just manage an RDS behind the scenes. There's nothing to stop it doing that. If it can create a load balancer, it can create an RDS cluster. And finally, what's in it for the cloud vendor? And that's really where we come back to this. We come back to this wall of products that you have no chance of beating anytime soon. And now just imagine for a moment not having to compete with it, offering instead a catalog of managed open source products with first-party support. So you want a database, you can go to MongoDB Inc., and they will basically be responsible for that. You have a support contract with them. You want queues, you go to Kafka. Whichever of these products you choose, you can go straight to the open source vendors. And while that probably doesn't work in all use cases today, it certainly seems a very, very attractive possibility a little bit down the road. And with that, I wanted to say thank you very much for your time and listening.
Excellent. Do we have any questions for Gerald? Remember to unmute yourself before asking. All right, I have a quick one. Gerald, why was Essid adopted in Kubernetes?
That is a very good question. I think at the time it was about the trade-offs. There were a number of key value stores that were attractive. Essid, it was written in Go. That's probably not a wonderful reason, but basically it was attractive to have one language stand up the whole stack. So if you look for key value stores written in Go, your choices dwindle quite considerably. And so I think that was really where that came from. So they had reasonable set of trade-offs. It was quite well executed. And again, this was CoreOS. CoreOS had a knack of actually being exactly in the places where it mattered. It is, if you look through the history of Kubernetes, it's incredible how much influence, how far above their weight they've punched.
I was reading a different angle on this, which was that Essid at the time was a very new project, and Kubernetes thought that because it's a new project, they can actually shift it the way they want and make it match the needs for Kubernetes. I think they were also considering Redis at the time, but because Redis was more mature, they couldn't actually change it the way they needed, so they ended up going with Essid.
Oh, that's really interesting. That makes perfect sense. Yeah.
Okay. Any other questions?
Yeah, one I like actually goes right back to the start of your talk, Gerald. But it was one that like has occurred to me and I've spent some time thinking about before. Yeah, so my question is more about, at the start you mentioned Heroku, and like, yeah, how can I forget? Like, I think Heroku, you know, I was talking about serverless today. If you'd asked me in a year before I found serverless, Heroku was that magic moment where it's like, wow, this actually makes my life easier. It's like, this is great. Why do you think, and now, you know, like it's a lot, I think a lot of companies are sort of trying to build up a pretty similar capability to what Heroku and stuff are doing. You know, a lot of places are doing in-house. I think like a lot of us, that's what we work on. What do you think, and I've got some answers myself, but what do you think it like offers to a company to sort of do these things in-house as opposed to looking to like a vendor?
It's a really good question, because it seems that most clients in the end build very similar things. So I do see some consolidation coming to this space, in the sense that I think companies probably do too much work on their Kubernetes clusters. They spend too much time finessing details of it, and then everybody in parallel does the same work. And much of that feels quite undifferentiated. So this is more of the heavy lifting that we've typically tried to avoid. But I wonder, it's a tricky one. I do think now that you've got the managed services, that's a little less hard to answer. I think sometimes business problems do call for bespoke solutions, and then Kubernetes makes it especially easy. So writing a controller really is a wonderfully quick, elegant way of solving that problem. And it's easy to unit test, it's easy to put together, it's easy to send up in your cluster and be as part of your automated offering. So it feels like it gives you a lot of power as developers. And then that is really what it taps into. And I think what it comes back to always is that reconciliation loop. It's just no other control plane gives you that today. This sense that you throw it in and you don't actually have to worry typically about the order you throw things in, because they will reconcile over time. as long as they're basically made known to the API server. The API server will sort it out. And I see that as really being the thing that certainly drives developers coming to the platform. And that's why there's just so many controllers out there. And it feels very vibrant. And but whether it's a good reason, I'm not as sure. The funny thing is, I don't know of a Heroku that isn't a service that's managed for us. In a funny way, sort of, you wonder sort of where's the Kubernetes that just basically just install this Helm chart, it'll basically give you Heroku, and that hasn't quite materialized yet.
Oh, thanks very much.
I'm gonna not say anything about that,
But you want to?
I want to, but I'm not going to. Not yet.
It would be interesting, actually. I'd be very interested from the vantage point of Salesforce, yeah.
Okay, I guess we don't have any more questions. Can I ask people to use the participants panel again and go to the buttons, yes or no? The question is, do you use Kubernetes in production at your day job? Or thumbs up. Cool, so quite a few people actually use Kubernetes at work. All right, so I think this was very relevant to the audience. Good to know. Right, so thanks everyone for attending. We'll have another event in 1 month with different talks. So please keep an eye for updates. In the meantime, you can use the Slack channel to get in touch with the rest of the community.